Hello, Alexis in Los Angeles. This is Rich down here in San Diego. Okay, we're going to try to walk you through this homework assignment. We're going to make a video. All right, so number one, you have a correlation between stress levels. That's one continuous IV, and your other one is job dissatisfaction levels. That's your second continuous IV. So yeah, you can run a correlation. So remember, a correlation tells you the strength and direction of the relationship between two continuous variables. All right, so now we're going to go back up here. All right, so the correlation between stress levels and job dissatisfaction levels is very high. Okay, so in other words, if stress levels goes up, so do dissatisfaction levels. Okay, so let's go back to question 2. So firm A has a high mean of job dissatisfaction levels compared to firm B. So if A had high job dissatisfaction levels, they're going to have high stress levels as well compared to B. So there's your answer for that one. That was pretty easy. And statistical technique, assessing whether Dr. Jones's statement of that one of these other variables could be causing the relationship, that makes it a partial correlation check. And number 4 is going to need a lot of calculations. So the question is, what is the correlation between JDS and SL if you control for ODS? So hold on. All right, a partial correlation is when you try to ferret out the effects of a different variable and its relationship to the existing variables in a correlation. So this problem is stating about the correlation between JDS and SL. They give it to us. It's 0.789, which is very strong. So in other words, when JDS goes up, so does SL, and vice versa. When it goes down, they both go down. So we're going to check to see if that's in fact a real cause and effect situation or not. Dr. Jones says that there could be something that is interfering with this relationship or being the real cause of this relationship or affecting what's really happening besides the JDS and SL. And he says here's some correlations between ODS and SL, which is again pretty strong, 0.832, and between ODS and JDS is 0.949, which is, these are very strong. So Dr. Jones is saying that you better check the correlation between JDS and SL while controlling for the effect of ODS. We're going to use the following formula to answer this question. So what we're looking at here is the correlation between X and Y, right? Rx of Y, the correlation between X and Y while controlling for Z. That's what that little dot means. So everything to the right of the dot is what we're going to control for. So in our problem, hold on. So here's the data from the homework sheet. First thing I'm going to do is put it in the correct orders. XZY, I'm going to change it to XYZ. And the X is the JDS, the Y is the SL, and the Z is the ODS. So what we're going to look at is the different correlations, which is given. Hold on. Right? We get all these correlations. These are given to us. So we're going to put those into just what we call a correlation table. We're only going to put them in this table strictly for ease of use. Okay, so we're going to fill in the correlations over here. Hold on. And again, this data is given to us. So like this one right here, this 0.789, that is the correlation between X and Y. That is the correlation between JDS and SL. This number right here, 0.832, that's the correlation between Y and Z, or S and SL and the ODS. Okay, so that's how you read that. So the only reason we're going to use that is to fill in the blanks into this ginormous formula. Right here. Oh my goodness gracious. So again, this is the correlation of X and Y, X and Z, Y and Z, etc., etc. And we have all that data from the table. So we're simply going to go ahead and substitute the values, right? The R of XY, that was 0.789. And the rest of these, again, let me show you again. Those are strictly from our correlation table, right? We know those values. So we're simply going to plug in all the values and do a lot of math. Do a lot more math. One more time. Take square root, divide, shkabam. You'll notice that that number is practically 0. So what that is saying is that when you statistically control for the OSD variable, the correlation between JDS and SL is practically zero. In fact, there is no relationship, right? There is no cause and effect between SL and JDS. It's only that the OSD variable is making it look like there's a relationship between the two. So the answer to number 4 is 0, right? After controlling for the effect of ODS, there is no relationship between JDS and SL. Boom. So number 5. So what we're talking about here is ODS is a confounding variable. In other words, it's affecting the results of the first relationship, unbeknownst to everybody. So that's what we call a confounding, lurking. It goes by many names, but this is the right answer right here, confounding variable. And then the conclusion that we can make is A is not correct. Right? There is no relationship between JDS and SL. It is negative, but it's so close to 0 that it's not significant, so don't say that. But this looks like the answer. The original positive relationship between the two variables appears to be spurious. In other words, it's not a real relationship. So there's your answer for that one. So let us move on to number 7. So we have to find the correlation between JDS and SL. So we're going to do this real quick in Excel. Please hold. So pick a cell, any cell. Click here. You're going to go to the function bar. You're going to go to statistical. Scroll down to Corel. And click OK. So your first array is your first column. So make sure the cursor's blinking in array 1. You're going to click those. So there's your X values. Click the button in array 2. Click and drag your Y values. Click OK. There is your correlation. So I don't know if you guys have to calculate your correlations by hand, but here's the formula. I'm going to try to run you through this really quick. Try to keep this video as short as possible. So here's the formula. So we're going to find the mean of each of the columns. So let's click the cell, go to the function bar. It's that little f of x right there. We're going to go to statistical. We want the average. And we simply tell it what we want the average of. That's this guy. Click enter. Done. So there's the average. And let's do the standard deviation. Since we're here, we're going to go to the function bar, f of x. Make sure you're in statistical. Scroll down to St. Dev. And we're going to use the population St. Dev. That's the St. Dev point P. Same thing. You're going to click and drag the data. Click OK. So now we have the mean and the standard deviation. And we will simply hit Control, copy, go over here and paste. So it did it both for them. Give me a second while I clean it up. All right, so here's the mean minus the x value. That's this column right here. And after you subtract the individual piece of data from the mean, you're going to divide it by the standard deviation. So that's what these numbers represent. And these are the counterparts for the y. So our next to the last calculation was we're going to go ahead and multiply these by these. So hold on. All right, so this first number, 1.92, is the product of this times that. So we're just going to go ahead and do all of those. Hold on. Okay, again, the green lines here are the product between divided by standard deviation, divided by standard deviation. So now we're going to go ahead and sum those. We're going to click the auto sum. And we just want these in there. Click enter. So there's the sum of the products of all that individual minus the mean times the other individual minus the mean divided by the standard deviations of each one. And now we're going to divide that by n minus 1. So we're going to divide that by 3. I'm sorry, divide by 4. Because this is a population, you're going to divide by n, not n minus 1. So this is the hand calculation of our correlation between those two. So the answer to this one is this one. Okay. So my suggestion is do it in Excel or SPSS, and if you have to, do it by hand. We do have videos on Hawk 1 and Hawk 3 on how to do that by hand. So, but that's it for 7. Since this video is getting longer than I thought it was, so I'm going to show you how to do number 8 using Excel. I hope this is okay with everybody. So we're going to go ahead and regress X on Z. Let me make sure that's right. That looks right. So Z is the independent variable, X is the dependent variable. So here's the big shortcut. You're going to go to Excel. Hold on. And under the Data tab, you're going to swing it all the way to the right, and you're going to click Data Analysis. And it's going to pop open a box for you. Hold on. And you want the regression that starts with R. You're going to do the regression model. You're going to click OK. Hold on. Let's get this right. Regression, OK. And input range is going to be your Y value is your output. So that's going to be your X column. Click here, and your input range is going to be your Z. So you're going to click and drag your Z. And you want to put the residuals on there. And that's probably everything else real quick. We don't really care about confidence intervals. You're going to click OK, and then it's going to take you to a magic page. Hold on one sec. And here's all the data from the regression model. So the first question, number 8, is they want the intercept of A. In other words, that's the constant from this output. So the constant is the intercept is 2. So the answer is 2 to number 8. Right? 2, that's number 8. And the slope is the other number, right? This is the slope number right here. So the slope is 0.5. 0.5. And which column contains the correct scores for the residual variables? That one is actually pretty easy to do too with this new function. Hold on. So we're going to scroll up, and there's the residuals right there. So there's the residuals when we regress Z on X. -1, 1, 1, -1. So that looks like, where is it? -1, this one, right? Double check. Negative, positive, positive, negative. Negative, yeah, that's the right one. So there's the answer to that one. So now let's do 11. So number 11, you're gonna do a different regression. Z is the IV this time, and Y is the DV. So we're gonna go ahead and use that shortcut again in Excel. We're going to, all right. So I'm gonna do the same thing. I'm gonna go up to the Data tab. Click the Data tab. I'm gonna swing it over to the Data Analysis one. And we're going to do the regression trick again. Come on, you. We're going to do regression again this time, but Z is we're going to go ahead and clear these ranges. This time your Y range, that's your output. The Y is the DV, so we're going to go ahead and click here and highlight the Y numbers. And then the X1, the input range is the Z numbers. Click and drag the Zs. And again, residuals, etc., etc. Click OK. And we get the magic box. Let me scoot the screen over. And this tells you everything you need to know. So question 11 is, what is the intercept of Z being regressed on Y? The intercept is 0. So there's that answer. Boom. And then what is the slope of this next equation? Let's just pull that up too. The slope is 1. So for question 12, the slope is 1. So it looks like you're going to do a different one. So for number 13, you're going to, the residual in the regression of Z as the IV and Y as the DV. So again, we're just going to look at the residual tables. They're right here, right there. So it's -2, +2, -2, +2. Switch back to this. -2, +2, -2, -2, positive. So it looks like this one. That looks like the right answer. And number 14, what is the value of the correlation between X and Y when you control for Z? Okay, I think that's the one we just did the video for, so hold on. So the way we set it up, question 14 is the exact same as question 4, right? It's if you want to see how you find a partial correlation after controlling for one. X was our JDS variable, Y was our SL variable, and the Z was the OSD variable. So we basically, 14 and 4 are the exact same problem. I could be wrong here. But the answer is, again, 0, right? Once you partial out the z, the OSD variable, the correlation between x and 0 is practically 0. So there's the answer there. And again, the relationship between JDS and SL is the same as number 4. It's spurious, so I don't understand that. But that's it. I hope this helps. MGZ, out.